Good morning, students. Today we'll be starting with exercise 4.2 tabular method of calculating limits. Now this particular method is not there in your syllabus, so this entire exercise is not to be done in your fair notebook. It is just for your understanding. We'll start with the first question, finding the values of the following using the tabular method. Limit x tends to 1, 2x plus 1. Now here we can see that the value of x is equal to 1. So for calculating the tabular method, in the first column, we'll be subtracting 1 minus 0.1. So we get the answer 0.9. Now putting that in the equation of f is equal to 2x plus 1. In the x value, we'll be putting 0.9. So we get the value of fx as 2.8. Similar form, in 0, 1, subtracting from 1 for the second column, 1 minus 0.01. So we get 0.99. If you put 0.99 in the value of x in the equation of fx is equal to 2x plus 1, we get 2.98. Moving down to the third column, that is we get from 1 when we subtract 0.001. Then we get 0.999, and when you put in that equation we get the answer as 2.998. And for the last column, we will subtract 1 minus 0.30 and 1, so we get 0.999. That means we will do this up till we get the 4 digit like this. So 0.99, 0.99, sorry 0.9, 0.99, 0.999 and 0.4 times 9. And when we solve that equation putting the value of x like this, we get 2.8, 2.98, 2.998 and 2.998. In the same form, moving on to the other side of the table, now we have to add, as we have subtracted 0.1, 0.001, 0.001, we'll be adding those same figures now to get the values. So firstly 1 plus 0.1. So we get 1.1, and we put that in the equation of 2x plus 1, we'll get the answer as 3.2. In the next table, second column, we'll be adding 1 plus 0.01. So we get the answer 1.01, and when we calculate, we get 3.02. In the third column, 1 plus 0.001, so we get the answer as 1.001, and the final output as 3.002. And in the final one, 1 plus 0.30 and 1, so we get the output as 1.301, and the final, when we put that value of x, we get the answer as 3.0002. Now what can we conclude from the table is that when the value of x is brought nearer to 1 by increasing, as we have seen, or by decreasing its value of fx, it approaches to approximately 3. We can see 2.998 and here also 3.002. So we can say that the final answer is limit of 2x plus 1 is equal to 3. It's by mistake written 13, it is 3. So with that we complete off with the first sum. Coming down to the second sum, wherein you have been given limit x tends to 3, x square minus 2x minus 3 upon x minus 3. Now we shall take the values of x nearer to 3 and prepare a table in the same form, subtracting 0.1, 0.001 till we get that 4 digit numbers, and same way adding up the numbers, that is 3 plus 1, 0.1, 3 plus 0.01, 3 plus 0.001 and 3 plus 0.001. So now let us see the table form. In the table form we can see when you subtract the numbers of decimal 0.1 from 3, we get 2.9. So multiplying it with, by putting in the equation, we get 3.9. Then coming down to the next one, we get, when we subtract 3 minus 0.01, we get 2.99, and by putting that in the equation, we get 3.99. Similar form, when you subtract 3 minus 0.001, we get 2.999, and putting that in the equation we get 3.999. And the last one, 3 minus 0.0001, that is we get by 4 digit numbers 2.4 times 9, and by putting that in the equation we get 3.4 times 1. Same way, adding up the total in that particular column, that is in the first column, 3 plus 0.1, so 3.1, the output comes down to 4.1. When you add up 3 plus 0.01, we get the answer as 4.01. When we add up 3.001, we get the answer as 4.001. When we add up 3.0.0001, we get the answer as 4.0001. So, from the table it is clear that when the values of x is brought nearer to 3 by increasing or decreasing, we can see the value of fx is reaching to 4, that is 3.4 times 9, and by adding up we get 4.0001. So, the equation's answer for limit x tending to 3, x square minus 2x minus 3 upon x minus 3 is equal to 4. Now the same equation of x square minus 2x minus 3 upon x minus 3 can be simplified, and the answer that you get in that would be x plus 1. This is a tedious method. If you put down the values in the same equation, it can be simplified and it can be done as we are doing the next sum. That is, in x plus 1, if you put down the values, you will get the same answer as 4. Coming down to question number 3, here we have used those methods of factorization. So, the above sum can be done by this particular method also. The next sum is limit x tends to 2. The equation is 2x square plus 3x minus 14 upon x minus 2. Now, if you simplify 3x, what we get is 2x square minus 4x plus 7x minus 14 upon x minus 2. For the simplifying, we get 2x plus 7 as one of the factors and x minus 2 as the other factor, and upon x minus 2. So, both x minus 2 gets cut. What remains is fx is equal to 2x plus 7. Now, if you put the value nearer to 2, that is subtracting 2 minus 0.1, we get 1.9. We put down that in the equation of 2x plus 1, the value of x, we get 10.8. Again, subtracting from 2, 0.01, we get 1.99, and putting that in the equation of 2x plus 7, we get 10.98. The third one, subtracting 2 minus 0.001, we get 1.999, and the equation's answer we get 10.998. And the last sum, last column, 2 minus 0.0001, we get 1.4 times 9, and the output comes to 10.9998. So, it's approximately nearing to 11. Again, instead of subtracting, now we add up 2 plus 0.1, so we get 2.1. The outcome of by putting the value of x, we get 11.2. In the next column, 2 plus 0.01, we get 2.01. So, the output comes down to 11.02. In the next one, 2 plus 0.001, we get 2.001. So, the output comes down to 11.002. And the final, in the fourth one, we get 2 plus 0001, that comes down to 2.0001. So, we get 11.002. So, you can see when we are subtracting, that is we are decreasing, we get 10.998. When we are increasing, we get 11.002. So, when the value of x is brought nearer to 2 by increasing or decreasing the value, decreasing its value of fx, it approaches to 11. So, we have seen how by both the methods, by putting in the equation as it is given, if you put the value of 2, if you put the value of 1.99 also will get the same thing, and if we if we do factorization and get one equation, in that also we'll get the same answer. But the second method is more convenient and less tedious. Now moving down to our fourth sum, that is limit x tends to minus 3 to x square plus 9x plus 9 upon x plus 3. We have factorized the thing, and what answer we got is fx is equal to 2x plus 3. Again, When we take the values of x nearer to minus 3, we get minus, that is by subtracting minus 0.1. So minus 3 minus 0.1 will give you positive negative answer minus 3.1. Again minus 3 plus minus 0.01, we get minus 3.01. Then minus 3.001 and minus 3.001. Now when we put the value of x in the fx to x plus 3, what we get is 2 into minus 3.1 plus 3. So the output comes down to minus 3.2. 2 into minus 3.01 will give you the plus 3 will give you the answer minus 3.02. The next 2 into minus 3.001 plus 3 gives the answer minus 3.002, and 2 into minus 3.001 plus 3 will give you the answer minus 3.002. So we can see the value of x coming nearer to minus 3 approximately. Now if we add up, we get minus 3 plus 0.1, so the answer comes to minus 2.9, and putting that in fx we get the answer minus 2.8. Minus 2.99 into that is how we get minus 3 plus 0.01, so we get minus 2.99, and the output comes down to minus 2.98. Then minus 3 plus 0.001 we get minus 2.999, and the output comes down to minus 2.998. Minus 3 plus 0.001 we get minus 2.4 times 9, and the output comes down to minus 2.998. So the value of x is brought nearer to minus 3. The value of fx will approach to minus 3 by increasing or decreasing its value. So from the table we can see that the answer for limit x tends to minus 3 to x square plus 9x plus 9 upon x plus 3 will give you the answer as minus 3. Now moving on to the fifth one of question number 1, that is limit x tends to 2 is equal to x. Now fx is equal to x, so we shall take the value of x nearer to 2 and prepare the table accordingly. So again the same thing, 2 minus 0.1 will give you 1.99. Putting that in that, we get the answer as same as 1.9 because fx is equal to x. That is f 1.9 is equal to 1.9. Then 2 minus 0.01 will give me the answer 1.99. The same value for fx, same way 2 minus 0.001 will give the answer 1.999, and 2 minus 0.001 will give me the answer 1.4 times 9. The fx will remain same. Now here you can see the value of fx coming down nearer to 2 when you are in decreasing. Now when we increase it, let us see where it reaches. So 2 plus 0.1, 2.1, and the output is also 2.1. 2 plus 0.01, that is 2.01, the output is 2.01. 2 plus 0.001, so we get the output as 2.001, and 2.001 will give the answer 2.001. So we can see that when the value of x is brought nearer to 2, either by decreasing or by increasing, the value of fx also approaches to 2. So with that we complete off question number 1, all the 5 sums in that. Now moving on to question number 2. Using the tabular method, show that the limit x tends to 3, 2 upon x minus 3 does not exist. Now let us see. Here fx is equal to 2 upon x minus 3, so we shall take the value of x nearer to 3. The table we can see 2.9, so when we put down in that equation we get minus 20, 2.99 minus 200, 2.999 minus 2000, and 2.4 times 9, that is minus 20,000. Same way if you add up 3.1, 3.01, 3.001, 3.001, the positive numbers that we get is 20, 200, 2000 and 20,000. So now we have already learned how to calculate the value of x over here, that is subtracting 0.1, 0.01, and same way adding up 0.1 with 3. So we get the following table. Now from the table we can see that when the x is brought nearer to 3, the value of x, fx does not approach to a particular value. That is when x tends to 3, fx does not have a particular value. So the limit of function does not exist over here. As we had seen in the earlier sums, we got a definite answer somewhere nearer to that number. But here it does not exist. Coming down to question number 3, the last second sum of this particular exercise. If y is equal to x square plus x minus 6 upon x minus 2, show that x tends to 2 and y, then when as x tends to 2, y tends to 5 using a tabular method. That is, when we put down the value of x as 2, we will be getting approximately the value of y as 5. Let us see whether it happens or not. Now, by using the factorization method, when we factorize x square plus x minus 6, we get x plus 3 and x minus 2 as the factors. Eliminating the similar factors, that is x minus 2 below and above the numerator and the denominator, what we get as the answer finally is x plus 3. Putting out the values and finding out when x tends to 2, what we get. So that is 1.9, 1.99, 1.999 and 1.4 times 9. The value of fx 4.99, 4.9, 4.99, 4.999 and 4 times 9. That is, we can see when the value of x is when we are increasing it, when we are decreasing it, we get it to 5. Now let us see when we are increasing. So we get 2.1, 2.01, 2.001, 2.0001. So we get the answer of fx as 5.1, 5.01, 5.001 and 5.001. So we can see when x is tending to 2 or brought nearer to 2, then the value of fx, that is y, will approach to 5, 4 times 9 and 5.001. Now moving on to the last sum of this exercise. If y is equal to 5 minus 2x, that is, as x tends to minus 1, show that y is equal to 7 using the tabular method. Now using the method, we can see, let us take the value of x nearer to minus 1 and prepare the table accordingly. So minus 1.1, that is subtracting minus 1 from that 0.1. So we get minus 1.1, subtracting from minus 1, 0.01. So we get minus 1.01, subtracting from minus 1, 0.001, we get minus 1.001, and the last we get subtracting from minus 1, 0.0001, we get minus 1.0001. And the value, when you put that in 5 minus 2x, we get 7.2, 7.02, 7.002 and 7.002. So we can see that when x is tending to minus 1, the fx value, that is the y value, is nearing to 7. Now let us see when we add it, what we are getting. So minus 1 plus 0.1 will give you minus 0.9. Putting that in the equation, that is 5 minus 2x, we get 6.8. Putting down the value of subtracting, adding minus 1 plus 0.01, we get 0.99, and adding up we get, putting that in the equation, the output comes down to 6.98. Against then adding minus 1 plus 0.001, we get 0.999, and the output comes down to 6.998. And for the final one column, that is minus 1 plus 0.001, we get 0.4 times 9, and the output comes down to 6.998. So when the x is brought nearer to minus 1, the value of fx approaches to, x tends to minus 1, we get the value of y as tending to 7. So with that, we complete off. We can see that what they have given, when x is tending to minus 1, y will be equal to nearing to 7. With that, we complete off exercise 4.2. This is not there in your syllabus. It's just for your understanding. Thank you.